Welcome to the Help Center, Work and Energy, multiple choice 2, problem number 5. Good question number 5 because it involves power, and that's we don't only see that sporadically. When we do, it usually does throw students off a little bit. It just throws in the idea of time, and in this case, it's really subtle. You really even hardly have to think about it in a way. So, constant force, 900 newtons, pushes this thing up the incline, shown at a uniform speed of 4 meters per second. Okay, so really, they just want the power developed by that force. So it really doesn't matter that it's up an incline even, to be honest with you. Power is change in energy over change in time. Change in energy is a real vague idea because power can be a lot of things. It can be the way energy is used in an electric circuit, which doesn't look anything like force times distance, or in this case, it could be an amount of work done as well in this case. So here it is, you can look at it as the power generated by that force would be the work done by that force, by the 900 Newton force, divided by time. That's a legitimate way to look at it. This idea of change in energy is really, it's a catch-all for all kinds of different scenarios. But in this case, that force is doing work, and we can look at this as work. So, what you can do is, all right, so power is going to be the work done divided by the time. Let's just focus on that work. Work is force times distance, and we need distance. Well, here's how this problem is subtly sneaky. There is a distance here. They don't tell us how far it goes, but we do know that in 1 second it does go 4 meters, right? If it goes for a second, it'll move 4 meters. So we can look at this as, let's say the object moves 4 meters. So it'd be a 900 Newton force times 4 meters, and you're like, well, where'd the second go? Well, the good news is we need some time. We need a time anyway in the denominator. So this 4 meters, this amount of work would occur in 1 second. So your delta t is built into the velocity. Right here is really just your velocity. And so that's how this is kind of tricky, because they don't explicitly say they have a time, but it is kind of the idea of a time here is built into the velocity. So it's simply going to be 900 newtons times 4 meters and then divided by 1 second. So this is one of those, it's going to be 3,600. This is one of those where you look at the thing and you multiply the two numbers involved, a couple of the numbers involved, and you get one at the end and you're like, okay, I guess, I don't know what a watt is, and you would get lucky and get it right. Probably not a lot of these on the actual AP exam, but yeah, this is one of those times in physics where you might just randomly multiply two numbers and get the right answer, but have no idea what you're talking about. We want to try to avoid that process. We want to make sure that we know what we're talking about at all times. All right, so there's number 5.